Chapter 13. In this chapter, we're dealing a lot with data. How data is collected, how it's expressed, how it's explained. Now, you may not be a researcher when you grow up. That's fair. But you will be bombarded and already are being bombarded with lots of info that people claim to be good data, which I mean it often is. But you need to know how to read this, how to understand it, so you can interpret it correctly. So measures of central tendency is what we'll be dealing with in this first section. So when numbers are collected from a group of people or objects, the job of a statistician is to measure and interpret the numbers in such a way that it is helpful for the people seeking to understand the data. And you can say data or data, both are correct pronunciations. Now, finding a single number that helps represent the whole group of numbers is often the first thing they find. A number that can do that is called a measure of central tendency. I think in our algebra book it just calls them measures of center. Same idea here, measures of central tendency. So the measure of central tendency, there's three, and you've probably heard these words before. There's the mean. That's the sum of the data divided by the number of terms in the data set. In other words, if I have 3 test grades and I know my test average, I add those 3 test grades together and divide by 3. That'll tell me my test average or my test mean. Then there's the median. Just like the median in the road is in the middle of the road, the median is the middle number of data ordered from least to greatest. Now, if there's 2 numbers in the middle, you just take the mean of those 2, and that works as your median. In other words, let's say we have 3, 7, 7. Okay, those are 3 numbers. The one in the middle is 7. That's the median. Now, let's say we had 3, 7, 8, 9. That's 4 numbers, so the 2 numbers in the middle are 7 and 8. So this one would have a median of 7.5, because that's the mean or the average of 7 and 8. So when there's an odd number, you'll have just one number in the middle. When there's an even number of data points, then you'll have 2 in the middle, and you have to take their mean to find the median. And the mode. The number of numbers that occur most often. So there's no mode in this list, but if I went ahead and added a 9, then we'd say the mode is 9 because 9 appears most often. Or if I was assuming these numbers are not in order, I added a 3, then we can say the mode, can have 2 modes, so we'd say it's 3 and 9. So let's try to find the mean, median, and mode of this data. So this is the House of Representatives in each of these 10 states. Now you may know this already, but I'll take the chance to make sure you do. Our legislative branch is separated into the House of Representatives and the Senate. And now in the Senate, every state gets 2 members, 2 senators. But in the House of Representatives, it's based on the population of your state. So the more people you have in your state, the more people you're allowed to send to the House of Representatives. So that's why you can see California has such a large number, because they're the most populous state. New York's is also big, Florida's is big, Texas is big, because they have lots of people. These other states I have listed are more medium in population, so they have lower numbers. So to find the mean, we add all 10 of these numbers together. So you can do that in your calculator. If you add all 10 of them, you get 236. Then you divide by the number of ones they have here, which is 10. So when you do 236 divided by 10, we get 23.6. So the mean or average number of representatives that these 10 states have in the House is 23.6. Now, to find the median, we need to list these numbers in order from least to greatest. So let's see, as far as least, I see 2 13s, New Jersey and North Carolina. So I'm going to check by those two. So I know I've covered them in list 13 and 13. Next up is 15, Michigan. Just put a check to make sure I don't do anything twice. Let's see, 18 looks to be next. That's Ohio. Illinois is 19. Oh, Pennsylvania is also 19, so we have another 19. Next up is Florida with 25. New York with 29. Texas with 32. And then the last one is California with 53. Okay, so when you're trying to find the median, one way that people often use is say, cross off the biggest and the smallest. You gotta do it together. So cross off the smallest and the biggest. So now I've narrowed it down to 8. Cross off the smallest and the biggest again. Now we're down to 6. Cross off the smallest and the biggest. We're down to 4. Cross off the smallest and the biggest. Okay, so we end up with 2 in the middle, but they're the same. So our median is 19. Now keep in mind, if those two numbers were different, you'd have to add them together and divide by 2 to find the median. Because when there's 2 numbers in the middle, the median is the mean of those 2 numbers. Okay, now as far as the mode, we're looking for the number or numbers that occur the most often. So we see 13 appears twice and 19 appears twice. All the others appear just one time. So we have 2 modes. They are both 13 and 19. Okay, Karen talked on the phone for 25 minutes, 39 minutes, 28 minutes, and 20 minutes over the last 4 days. If she talks for 34 minutes on the next day, which of the following would be true? The mean increases and the median decreases. The median is unchanged and the mean increases. Both of them decrease or both of them increase. Okay, so we're going to find the mean and the median for these 2 scenarios. So first of all, she has these 4 groups, 25, 39, 28. I'm going to put them in order so that'll help us find the median. So the mean, if you add all those together and divide by 4, adding them together gives you 112. Divide by 4, we get 28 minutes. So her mean was 28 minutes for the first 4 times. And the median, well, we have 2 in the middle. So 25 plus 28 is 53. Divided by 2 is 26.5. So the median is 26.5. So this is the mean and the median before we add on this next day. So let's see what happens if we add in another single number of data. So if you add these together and divide by 2, I don't know why I said divide by 2. Add these 5 together and divide by 2, you get 29.2. So just add those 5 together, divided by 5, you'll get 29.2. So that shows the mean has increased over the time. So we know the mean increases. Now let's talk about the median. Well, we cross these off. The median is the middle number, which is 28. So the mean has increased from 28 to 29.2. The median has increased from 26.5 to 28. So both of them have increased. So that means we pick D, both the mean and the median increase. Okay, Nico earned the following amounts raking leaves. If he drops the lowest amount he earned raking leaves, which of the following statements would be true? So So let's follow the same pattern. Let's start by putting these in order, all 5 of them, when we're including all of them, which he was at first. If you add all 5 of these together, you get 62, and then divide by 5, we get a mean of $12.40 for what he earned at these 5 times. Now the median, we cross off 2, is right here. The median is 12. So when he includes all 5 of his amounts, the mean is $12.40, the median is $12. Now he says if he takes away the time he earned the least, so he takes away the 8, and he wants to look only at the time he earned more, which is 10, 12, 15, and 17. So if you add all 4 of those together, it's 54, and divided by 4, and we get a mean of 13.5. So it makes sense, since we dropped the lowest one, the mean should go up. It's gone up from 1240 to 1350. I'm just including the zero since we're talking about money. So it makes sense to round the nearest penny. Then the median, we'd cross these 2 off, take the average of 12 and 15, or the mean of 12 and 15. So the median is 13.5. So that's also increased because we were $12 before. Now we increased to $13.50. So in this case, both the mean and the median increase. That will not always happen. It won't always be that both increase. You will really need to just check both in both scenarios and decide the answer. So one question, and this question is not just talking about the 2 situations we just looked at, but saying in general. So which measure of central tendency is best to use? Now it's explained pretty thoroughly at the bottom of our book, in our book at the bottom of page 775. But I will just say this for the sake of the video. The mean is very good when the data is essentially symmetric. So when you look, things are pretty evenly spread out, is what that means. So the mean is good when the data is symmetric. And by symmetric, you can just think about it's pretty evenly spread out. So if we were to take look at the ages of every middle school student, the mean is pretty good because pretty much all 6th graders are 11 or 12, all 7th graders are 12 or 13, all 8th graders are 13 or 14. So that's going to be pretty evenly spread out throughout the middle school. So the mean would be good if we want to know the average age of a middle schooler. The median is better when the data is skewed or there are outliers. So for example, if we're looking for the mean age of middle school students at our school, or a good central tendency measure, the mean is great when we look at the students. But if I were just say, let's talk about the ages of the people in our classroom. Well, you guys are either 7th or 8th graders, so 12 to 14. If I was including myself in that list, and I'm 40 at the time of making this video, I would make the mean get skewed pretty badly, because adding in a 40-year-old to a group of 12 to 14-year-olds, that's going to make the average go up unnecessarily high, considering I'm only one person out of the whole group. However, if you think about it, the median, just think about it this way. Let's just do a small number. Let's just say I took one of you that's 12, one of you that's 13, one of you that's 14, and then me that's 40. Now if I take the mean, well, the mean of these 3, the students, is 13. But the mean, once you include me, oh gosh, let's see, 39, 79, it's almost 20. So just adding my age in changes the mean from 13 all the way up to 20. Whereas the median, when there's just 3 people, is 13. The median, where I include myself, an outlier, is these middle two numbers, which makes it 13.5. So when things are not evenly spread, the median is not as affected by it as the mean. So when things are evenly spread out, the mean is great. It's the better option. When things are not spread out well because they're skewed, meaning there's a lot of highs or a lot of lows, or there's an outlier like adding my age into this group, the median is better. It doesn't get changed as much because of one high or one really low number. Okay, last one. The average wait time for 10 different rides at an amusement park are these 10 numbers right here. So which measure of central tendency would the amusement park advertise to show that the wait time for its ride is the shortest? So notice, it's not saying mathematically which one is best. It's saying, given your advertising for your amusement park, you want to make ride times seem low, or wait times, I should say. Wait times for rides seem low. So what's best for this business is to pick the lower of the two. Or of the three. Sorry, we need to look at mean, median, and mode. So for the mean, if you add all 10 of those together, you get 334. You divide by 10, because that's how many there are. You get 33.4 minutes. So the mean wait time is 33.4 minutes. For the median, let's put these in order. So we have 11 and 2 17s is the lowest. 11, 17, 17. Then we have 21, 22, 25, 21, 22, 25. Then 44, 52, and then 60 and 65. I think that covers all of them. Yes, that's a total of 10. So for the median, we cross off the first and the last, first and the last, first and the last, first and the last. We have 2 in the middle. So if we add those together, we get 47. Then divide by 2, we get 23.5. So the median is 23.5 minutes. Then for the mode. Well, the only number that appears more than once is the 17. So the mode is 17 minutes. So while I might argue, based on what's set up here, that the mean is the better response, because it reflects the fact we have some low ones and some high ones. These are spread out this way. What the advertisers want to say is that the mode is the best, because it's the shortest. So the mode time would be advertised because it's the shortest.